Hello everyone, welcome to the next lecture in our course. We are discussing about remote sensing data sets, data portals and some of the processing tools. In the last lecture we started discussing about remote sensing data and we saw example for like an optical data set and different levels of processing. So in the last lecture I told you like there can be like 4 different levels of processing in remote sensing data and not all the sensors and all the satellites provide us all the 4 levels of data. It depends on what sort of goals the space agency has and what they envisage to give us. Okay. So, just I showed you one example of different levels of data processing with an example of data acquired from VARS sensor, which is essentially like an optical sensor. In the same way we can also define the data for other sensors like synthetic aperture radar, passive microwave radiometers, LiDAR and everything. Just we will quickly see some examples for each of the data set. This slide shows an example for the different products available from the Sentinel-1 SAR satellite. It is like a synthetic aperture radar satellite operating in C-band. So, here also we have different levels of data even in different modes, like at the end of radar remote sensing lecture I told you it is possible to acquire data from a SAR satellite in different modes. We can either improve the spatial resolution by decreasing the swath width or obtain data over like a large swath or obtain like polarimetric data like data in different polarizations. All these things are possible from SAR satellites. Similar thing is also applicable to the Sentinel-1 SAR, like an example is given here in this slide. Say if you look at the data can be obtained in different modes: strip map mode, interferometric wide swath, extra wide swath. So, these things will differ whether we want a large swath coverage instead of like a very fine spatial resolution, or whether we want like a very fine spatial resolution but we do not want a wide swath. It depending on our needs we can choose the data, we can program the satellite to acquire such data. Here also we have level 0 raw data which normally may not be given to us. Level 1 data can be single look complex or ground range detected. So, ground range detected is like the slant range geometry of the data will be converted to ground range distance which we can use it for further processing, whereas a single look complex will contain both the phase information as well as the amplitude information of the wave that is received. So, these are like level 1 products what basically the SAR receives. Then further it can be processed as level 2 data, like it can be given like Sentinel the agency Copernicus gives data in like variables related to ocean like ocean wind field, ocean radial surface velocity and so on. So, these are some examples for data from Sentinel-1 SAR products. Similarly, if we move on to passive microwave radiometers where there are like different satellites available. I am just showing you one example for the SMOS data, which is again like an L-band radiometer dedicated for observing soil moisture, ocean salinity and even like freeze thaw rate it will be able to provide. So, the first level of data is the brightness temperature, which we all know like calibrated brightness temperature values. So, the level 2 is always geophysical product. So, brightness temperature is not like actual geophysical product, that is what like satellites observes. When you talk about like earth surface or its properties, then you can talk about like soil moisture. Soil moisture is one of like the state variable of earth system, or you can talk about vegetation optical depth, which is like the water content within the vegetation canopy, like you can think it in terms of like a 3-dimensional structure which holds water, or it is maybe you can say ocean salinity product if it is over ocean. All these things. So, level 2 will be such data sets on a swath based product. Swath based means like as and what the satellite covers they will give us the image. Then level 3 everything will be properly gridded to like a perfect grid, like earth can be divided into various grids and the data can be perfectly populated into those grids and it can be given to us with different temporal scale, maybe daily, 3 daily, 10-day once or monthly products. So, it is like a proper gridded product, maybe we will get like data for every globe. Say we know that each satellite will have more than one orbit in a given day across the globe, right. So, all the things will be properly combined to get us like a global product, that is one. And level 4, say whatever the SMOS observes they are like fed into like another model and they will provide some other advanced variables as output. Say in SMOS level 4 we also have like a very high spatial resolution product, like at 1 kilometer they are using like a disaggregation algorithm to do it. Similarly, if you talk in terms of SMAP satellite, which is another L-band radiometer available in space, again level 1 data is brightness temperature, level 2 data is soil moisture at SWAT level, level 3 is like global gridded daily soil moisture product, and level 4 can be a root zone soil moisture product or like a modeled 3 hourly soil moisture and so on. Okay. So, essentially these satellites, passive microwave radiometers, provide data related to brightness temperature, soil moisture, or some of the passive microwave radiometers may provide even like wind velocity over like oceans, sea ice thickness, all these things also can come as output from passive microwave radiometers. Then this slide shows example for LiDAR data products from ISAT satellite, ISAT-2 satellite basically from the Atlas sensor. Here also we have from level 0 to level 3 data. So, level 0 is whatever the satellite is sending, and level 1 data is actually like the level 1 data is basically the reformatted telemetry data, whatever is sent by the satellite it is converted into science units and like the distance, basically nothing much but the distance and other parameters. So, when the distance is combined with the precise orbit determination parameters and the precise position determining pointing parameters, like where the satellite is pointing and what the satellite orbit is, if these two are combined, then we will be able to estimate the ground coordinates of each and every point. That is the basic principle of LiDAR system I told you. So, that is also possible, that is level 2 data set. So, this level 2 data set will tell you like the geolocated photons, where like each photon hit its XYZ coordinates it will be giving. It will also give like a normalized backscatter profiles and all. So, then comes level 3. Level 3 is okay, this is geolocated photons. After when you do processing over it, we will be able to retrieve the thickness of ice, thickness of vegetation and so on. So, all these things are combined in given in level 3: land, ice height, sea ice elevation, land or water vegetation elevation, inland water elevation like level of inland water bodies and so on. So, all these things are level 3. So, level 3 can further be classified to level 3A and 3B. So, 3B has like a weekly product, gridded product and so on. So, these are some examples of data sets available from ISAT-2 LiDAR sensor. So, the major aim of me just giving examples of all these data products is to introduce the students who are new to this field, to tell them about like the wide variety of data available. Conventionally we think everything as in form of like a image consisting of like spectral DN values, spectral reflectance and so on, but remote sensing provides a variety of data sources which we can directly use for many different applications. So, that is the only reason I gave examples from different sensors. Okay, now we got like a very brief idea about what all like the different types of data that we can get. Now we will see what are the common formats in which these data are supplied. Okay, satellite has acquired some data, maybe an image or a non-image, but everything will be converted to some form of like a computer readable file format, and then it will be delivered to us. What are the common remote sensing data formats? Again I am telling this list is not exhaustive, I am just mentioning 3 of the most commonly used data sets. There can be many different data formats available, but we cannot list and explain all of them. I will just pick 3 of the commonly used data. The first one is like the GeoTIFF format, the most conventionally used format for images. Say when you acquire Landsat image or when you acquire like any IRS image, Indian remote sensor, normally you will be getting the image in GeoTIFF format. Like all the image, each image will be kind of like, you can think it in terms of like a photograph, like we can keep it in analogy with a photograph. You can, it is like a photograph of earth, okay. So, which you can visualize, and like there are like special softwares to open it, commercial based as well as open source freely available softwares are there to open it and visualize it. So, everything is image, it will be composed of like pixels, like many pixels will be there, each pixel may contain a DN or a reflectance and so on. So, each band will be represented by one image. So, for a Landsat satellite you can contain, say Landsat 7 had like 7 different bands plus a panchromatic band. So, 7 different bands plus pan all will have like total 8 images. So, each image corresponds to each band like that. But the only difference between a normal photograph and a geotiff is like, and a common man language I am telling, it is the addition of geographical information. In our normal photograph, we just take a photograph, it will contain the DN values, that is it. But here, since it is like a photograph obtained over earth, each pixel will have its own coordinate information. So, in general, for an image you need to provide over which area it is taken, there is something what is called like projection, there is something called datum. Maybe students coming from the survey background may know all these things. Essentially, they are all useful for defining the exact location over which the image was acquired. So, those information will be there attached with this TIFF. So, it is like a normal TIFF format, tagged image file format, but with geographic information. One of the most widely used format for imaging sensors, especially in the optical domain. Then comes hierarchical data format, HDF. So, this HDF is one of the very widely used format for dissemination of data acquired from different satellites, especially like sensors like MODIS, VARS, SMAP, even like some of the Indian sensors nowadays mostly give data in the hierarchical data format. It is like highly structured data format and also helps us to save memory. Like normally a geotiff image may be like of enormous size. If you try to download like a Landsat image, it may be close to like 1 GB. Whereas if each image can multiple variables. Just think of like a level 2 or level 3 product which can contain several variables. If we store everything in geotiff, it will become like huge enormous amount of data. So, HDF provides like a simple structured format where we can store the data. So, one example of HDF data is given here in the slide. So, this is like taken from SMAP L3 satellite, L3 data product. So, hierarchical data format basically contains groups as like their primary object. Within the groups there can be further subgroups or the actual data sets. Okay. So, here if you look, it has 3 groups. Metadata is one group, soil moisture retrieval data AM is one group, PM is one group. So, within this you can have several other maybe like data sets or another subgroups and so on. Say for example, land cover class, latitude, longitude, water body fraction, all these things are basically data. Soil moisture itself is a data, all these things. So, basically it provides kind of like a hierarchy. So, it is each one will be kind of like will provide you data. You can store a large number of data. You can think it each one as a separate band if you think it in analogy with geotiff. Okay. So, each one can represent either one data or some other information about the data or like metadata. Okay. So, it provides kind of like a hierarchical structure. But the only thing about like hierarchical data format is there are a lot of softwares available to open them, but at the same time it is also easy to process everything using like automated computer codes also. Like you can just open them, there are like again different libraries available in various languages, MATLAB, Python, R and all, where we can open them and process them, highly amenable to computer processing. We can just extract whatever data we want and without need to open like the entire data set that is there. The next commonly used again format is NetCDF, Network Common Data Format, similar to HDF5. Like HDF5 is like the version HDF5, 5th version of HDF format. So, it is NetCDF also similar to HDF and most of the climate related variables and all are given in NetCDF format. Okay. So, these are some of the commonly used file formats. As I told you earlier, there are again many different file formats available and most of the softwares, either commercial or open source softwares, are capable of opening this. And also if you want to program everything with respect to some sort of programming language, again there are specialized packages to open these data sets and use it. So, this concludes our discussions related to different data sets that are available, just a very brief discussion with few examples. Then we move on to remote sensing data portals. Okay. Different data sets are available that we now came across, but from where to download all these data sets. So, the place from which these data sets can be searched and downloaded are called data portals. Again there are large number of different portals available. Again we will discuss only some of the commonly used portals, and almost all the portals require the users to register beforehand, and they will send us some user ID, password and everything. Once we have access to it, we can search whatever data contained within it and download the data. This is one thing, and the same data set can be downloaded from different portals. So each portal is kind of like a small gateway. You can think like the data will be stored in some server located somewhere physically. So the data portal acts as a gateway, it acts as an interface between the data server and you. So what happens, as a user I will be searching for a data set. So it is like a very big building having different gates, same concept. A data server is there somewhere, but through each data portal we can gain access through. Search the data, okay, what the data contain, like I may be interested collecting data acquired during month of October 2020 over Mumbai. I can search such images maybe from Landsat satellite or Indian remote sensing satellite, like that. So the data portals will give me capability to search the data. Then I should be able to download it. Again that capability should be provided. So there are like different data portals available. We will discuss some of the commonly used. So these are some of the commonly used data portals: United States Geological Survey Earth Explorer, NASA Earth Data Search, Copernicus Open Access Hub, ISRO's Bhuvan and ISRO's MOSDAQ. So these are some of the things we are going to discuss, but again there are like plenty of other data portals, like there is something called NSIDC, National Snow and Ice Data Center, located in United States of America, which gives us access to SMAP data sets, ISAT2 data sets and so on. Okay. So there are plenty of data portals available, but we will restrict our discussions only to these. So first thing we are going to see is like the USGS Earth Explorer, maintained by United States Geological Survey. The web link is given there, earthexplorer.usgs.gov. One of the most popular web portal for searching and downloading publicly available spaceborne and other derived products. Basically it helps us to query the site, query the server. Query means like we can say, okay, this is my need, get all the data for it. So we can search for the data, have a look at the data, what we is called like look images. Okay. So we need not download the data immediately, we can just take a look how the data is, especially for imaging sensors. We can take a small look how the data is, then we can download. Okay. So such facilities are available. We can search, have a look at the data and then download it. Not only satellite images, but also thematic products such as land use land cover maps, elevation information are all available. One of the most commonly downloaded data from this portal is the Landsat series of satellites. So Landsat series of satellites are widely, they are kind of maintained by United States Geological Survey as the primary maintenance provider. So the data from Landsat satellite are primarily housed here. So this is mainly used for that. Apart from Landsat, we can also download data from Hyperion, which is a hyperspectral sensor. Even commercial satellite images like IGNOU and ObView 3, they are available. Then apart from satellite images, you can download digital elevation models, like I told you what digital elevation model is, right, basically. So that DEM is available from it. We can also even search and download data about MODIS, ASTER, even Indian remote sensing series of satellites, ResourceSat-1, LIS-3 sensor, ResourceSat-2. Many things are available from this data portal, which acts as like a gateway to multiple different data. So this is how the portal will look. So the search criteria, the first tab here, we can just mention whatever feature we need to search. We can either search based on a location, or we can draw like a small polygon on the map on the right side and we can decide, okay, over this you tell me, like that we can use, or we can give some coordinates. Okay, I have certain ground points, xy values. If I give it, then it will deduct those ground points, display in the map and search data for it. That is possible. We can search the data, which range to which range, what fraction of cloud cover I need. Normally for some application we may require data containing less than 10% of cloud. we can specify that. Result options, we can specify some search options and so on. So, after this we click this tab and go to data sets. Once you go to data sets, we have like, you can just see how much different varieties of data available: aerial images, AVHRR sensor, digital elevation model, EON satellite, HCMM, one of the oldest thermal mission, Landsat, NASA LPDAC, which is like the MODIS VARS collection, Sentinel, all these things, even ISRO ResourceSat. Many different data products are available. We can search them and download them through this data portal, one of like the widely used data portal. The next important portal is NASA Earth Data Search. Again, like the web address is search.earthdata.nasa.gov. If you remember the name of the portals, you can just search them in any of the commonly found search engine and get access to it. You need not even remember the web address. You can just remember, okay, this is USGS Earth Explorer portal, NASA Earth Data Search. If you remember the name, you can just search using any of the common search engines. You will be able to land up in those portals. So, that is like the beauty. It is so highly used, you need not even remember the web address basically. So, the NASA Earth Data Search portal provides us access to almost all of NASA's earth science data holdings. Okay. So, whatever data NASA collects with respect to Earth, most of them are available in public domain and almost all of them are available from this particular portal. Not only satellite images, data from model, ground based experiments like in situ observations, airborne observations, everything is available in this portal. Whatever NASA thinks it can be publicly given, they give it through this particular portal. Also, this portal you can download near real time data. As soon as the satellite acquires data, we will be getting it. This is highly important for meteorological applications or say volcanic observations, fire monitoring, natural hazard monitoring. For all these applications we need near real time data that can be downloaded within few hours of data acquisition that will come to our hands, or some data may have like a small lag time, say 2 to 3 days, 1 month, etc. Based on it, the lag time, the process data will come to us. So, all different kinds of data are there in this particular portal. And there are plenty of options. We can specify from which instrument we want. Say MODIS sensor itself is available in 2 different satellites, Terra and Aqua. Whether I want data from Terra MODIS or Aqua MODIS, I can specify. VARS sensor is available in 2 sensors, JPSS and Suomi NPP. We can search it like this. Many different satellites are there. Here again, not only images but also thematic products are available. Like you can choose, list me all the data related to atmosphere, it will list whatever is available. Then we can say list me all the data available to land use land cover, it will list. So, not only based on satellite images, also based on the theme in which you need the data. I need data, all the data related to global vegetation, it will list from which we can choose. Like this, that kind of facility is available in Earth Data Search. Say this is like the general look of this Earth Data Portal website. Here we can choose the date range, here we can choose how we are going to give our location over which we are interested. We can either give them in kind of like a bounding rectangle we can draw like this, we can give like a polygon, like if I want data over like this part of India, I can choose it like this, it is a polygon. I can give a point, okay, search me data at this particular point, or if I want to acquire data over New Delhi, search me data acquired over New Delhi, it may give. I can draw like a circle and give. So, all these options are available. Then just see like a different amount of data. It shows 7,104 matching collections, that is that much amount of different data products are available. So, whatever it is there, it is just listing. So, 7,104 different data sets with varying spatial, spectral and temporal resolution are available in this particular portal. Again we need to register before even we search or download a data. You can see Earth Data login. Definitely we should register, get a login, and then only we will be able to get access to the data sets. And apart from NASA, the other main space agency that gives publicly available space remote sensing data sets is like the European Space Agency, which is the data portal is the Copernicus Open Access Hub. So, again the website address is given here. So, the Copernicus Data Hub is an interface developed by the European Space Agency, and it provides free access to Sentinel products. So, Sentinel-1 SAR data, Sentinel-2 optical data, Sentinel-3 is kind of like it provides sea surface topography, land surface temperature, and also its thermal and combination of thermal and altimeter data, all these things. So, all these data are available from this Copernicus open access hub. See, again this is how the portal will look. We can like search by date range, we can search which mission we want, we can specify which platform, like Sentinel-1 is available, Sentinel-1A, 1B, Sentinel-2, 2 satellites, Sentinel-2A, 2B, like this we can search, and here we can draw like a small bounding box with which we can search the data. So, this is again like one of the popularly used data portals for searching and downloading Sentinel data sets. And among these portals, NASA Earth Data Search also provides us like a bulk download option. Bulk download means we can say for some of the applications I may be needing years and years of data. I may want to analyze last 10 years of vegetation data for my application. I need to do like a time series analysis. I cannot just keep on click download button so many thousand times to download all the data. It will give us like a single text file which will store all the URLs of all the data sets. We can do some sort of like automated scripts or use some sort of like downloading softwares. If we feed this text file as input to them, the download will happen automatically, like overnight we can just put the download, go and come back, and morning we will have all the data downloaded if our network is really fast. So, such kind of facility is also available, and it is there especially like in NASA Earth data portal, which we can directly download. One more commonly used portal is ESA's EO catalog, which is European Space Agency's Earth Observation Catalog. Again the website address is given here, eocat.esa.int, provides search and data download facility to many common satellite data sets, allows pulsar, which is like a L-band SAR data, SMOS, NVSAT, SPOT, Landsat. SPOT is again like an optical sensor, Landsat data. So, many different types of data are available. This is not very widely used, but still it has like enormous potential for us to search and download the data, and glimpse of the data portal is given here in this slide. So, this shows the search has been carried out for the SMOS science product for all the data acquired between October 1 to October 31 of 2020. Just a large bounding box is given covering like the entire Indian subcontinent, and these are all the orbits that SMOS had over this particular zone within this particular date range. Then we are moving on to data portals developed by ISRO. So, ISRO has Bhuvan and MOSDEC as their like primary data portals. See, Bhuvan is developed by NRSC, National Remote Sensing Center of ISRO. So, the web address is given here, bhuvan.nrsc.gov.in. So, it provides a platform to visualize, share, even analyze geospatial data products. Not only we can search the data and download, but we can also do some sort of simple geospatial analysis, like some of the thematic products, say land cover map is there, like ISRO is doing lot of thematic works also. They create land use land cover map, they use vegetation maps and all. We can just normally in our GIS software we can just take a link out of it. If we put the link here, the data will be available in our GIS software over which we can do our analysis, that is possible. So, it is also provides us some simple analysis tools. It has lot of capabilities. Actually ISRO conducts lot of training programs, online webinars, etc., to educate people about the usage and the huge variety of application for which these portals can be used. I just briefly introduce you people with this portal. Please feel free to explore, and there are like plenty of online resources available that are created from the ISRO side itself. So, the Bhuvan enables us to like do visualization of satellite imagery, maps, also its analysis, and whatever data is publicly available from ISRO we can search and download it. In addition to satellite data, several thematic products related to land, ocean, atmosphere and cryosphere also available from this portal. I need land vegetation, it is available. I need some variables related to ocean, available. atmospheric products available. So, all these things are we can do it. In addition to it, from the NRSC site we can also search for IRS images. Some of IRS Indian remote sensing satellite actual images, we have to search for it, order and pay some small money to get it. That facility is also available, the links are available within the portal. So, as I told you earlier, in Bhuvan portal, users can also use the thematic data sets in the portal and integrate into their systems as OGC web services, that is Open Geospatial Consortium web services. Whatever data is there, we can use it into our own applications. Application in the sense like I may have some software running in my computer, I may not be able to download all the data, but I can just take a link out of it where my software will work with the data along with my own data sets, combine everything, do like an integrated analysis. That is possible with the data available from Bhuvan portal, and it provides timely information on various calamities, especially natural hazards, heavy rainfall, droughts, all the again information will be provided in the Bhuvan portal. Say this is like example of how Bhuvan portal will look. So, this open data archive will take us to some of like the freely available data sets. We can choose which satellite sensor we want, which theme or product we want, like this we can choose. You can see this 2D and 3D portals provides us visualization. We can visualize various data sets. It provides thematic services. It provides data in different application sectors, what is needed for agriculture, what is needed for hydrology, all these things are available within this portal. If the data is not directly available within this, it will also provide us the links from where to get it within like the ISRO's domain. Okay, so that is the advantage of Bhuvan portal, one of like the highly popular data portals developed by ISRO, where almost all the ISRO data products can be searched and accessed. So, the next data portal which we are going to see is like the MOSDAQ, which is like the data repository again created by ISRO, but from meteorological missions. So, mostly it contains data acquired from satellites dealing with meteorological applications, oceanography and tropical water cycles. Say MOSDAQ portal archives and disseminates data from satellites such as INSAT, Kalpana 1, which are all geostationary satellites, OceanSat, Megatropic, SARAL, all these things. Okay, so, there basically it is for meteorological and oceanographic applications developed by most of the data are like available from the Space Application Center. Like the earlier the Bhuvan portal was from NRSC, National Remote Sensing Center, and this one it is from Space Application Center, but everything is like different arms of ISRO, but each one of them specialization different things. Again we have to register, we can search for the data and download it. See, this is example for the MOSDAQ portal. So, here we can INSAT 3A is one of like the geostationary satellite. Similarly, we have Kalpana 1, INSAT 3D, all those satellites are there. The data catalog is provided for different applications. You have data sets, all these things are available from this thing. So, MOSDAQ stands for Meteorological and Oceanographic Satellite Data Archival Center, developed by Space Application Center of ISRO. So, again even for this particular portal, ISRO has provided online webinars which are available in various platforms which users can see and get expertise within this data portal. Apart from this, ISRO is also developing a portal called Vedas, which provides us some sort of like analytical capability. We can do some sort of analysis over the data for acquired from different sensors. So, as a summary, in this lecture we have seen about like some of the commonly used data formats and also some of the commonly used data portals. I am repeatedly telling, I have just introduced you to the data portals. So, the interested students, they can explore more. So, and also one data set can be available from many portals and some data sets can be accessed only from a particular portal. Say INSAT 3D data can be obtained only from the MOSDAQ portal, you cannot search it for anywhere else, it will not be available. So, it is always better for us to know, okay, this is the satellite which I am going to use, from where I can get the data. If we know this particular knowledge, it will help us whenever we are doing some sort of research activity or a project activity. So, the interested students are always welcome and encouraged to explore all these portals and understand what are the capabilities of portal. They are not just data providing portals, they provide other few portals provide data analysis capabilities too. So, we are always free to explore that. So, with this we end this particular lecture. Thank you very much.